Welcome back. Now you've tested all your device connections with the vendor supplied software and everything is working fine. You've set up your configuration file, so it's time to actually try and connect with each device and make sure LabVIEW is talking with them as expected. The best way to do this is using a microscope module called the device panel. The device panel, which is what I'm showing here, is more or less like a dashboard that lets you stop and start low-level device engines based on your configuration file. You can also monitor which devices are running and send commands to stop all the devices from running. This is important because all the low-level device engines are running in the background with no visible front panel, so it's hard to know what's running and what's not. This is also the place to go if you want to stop a specific device engine or restart one. So the first question is, how do I access the device panel when I'm setting up? The device panel is located in the Microscope-Control repository under the Microscope Modules folder and then inside the Device Panel folder. The layout is pretty simple. At the top, there is a text box that shows what configuration file is currently loaded. Next, we have a list of all the devices as defined in the configuration file. I've drawn a box around the area containing all the info for the first item in my configuration file. For each device, we have, hopefully, a unique notifier name, sort of an address that LabVIEW uses when it's sending commands to the device. Next, we have the path to the low-level device engine set in the configuration file. Below that, we have the port ID/access information for the device. And finally, we have two buttons. The first can be used to start or stop the low-level device engine and also serves as an indicator for whether the device engine is running or not. When the device engine is running, this button will appear green. The second button is used to open or close the front panel of the device engine. Remember, all the device engines are running with their front panels not visible, but you can use this button to make their front panel visible if you want to troubleshoot something or check a parameter. Finally, there are two buttons at the bottom of the device engine. The one that I've boxed here is used to send a quit command to all the device engines if you want to stop all of them. And the second button will quit the device panel VI and also pop up a box asking the user if they want to quit all the running device engines. The overview of what's happening here is we're going to run the device panel and then try to run each low-level device engine individually. If everything works and they all run, then we know we're okay to start using the whole software package and start using the microscope. Now let's launch the device engine and check if each low-level device engine can run or if we've made a mistake and need to troubleshoot the device. Now let's open the microscope module folder and then the device panel folder, and then let's open the device panel. Let's run the device panel, and immediately it's asking what configuration file we want to use. Let's select the 4Pi configuration file we made in the previous video and click OK. Let's scroll to the top of the device list and then systematically work our way down the list and make sure everything runs without any problems. Let's start with the first item, which is a shutter, and once the running button stays green, we know that the device engine is running, and we can open the front panel and make sure the shutter is opening and closing as expected. We'll do the same thing for the second item, which is also a shutter.
And we'll keep going
and now
down
let's
the
test
list.
The third item, which is the sample XY stage. So we'll click run, we'll open the front panel, and now let's try and step the stage and make sure that the positions are updating. So I'm typing in a step size, and let's check the first axis and the second axis. Now let's do the sample Z stage. Let's run the device engine, and you'll notice that the Z stage has an axis named C, while above, the sample XY stage has axes named 1 and 2, and if you open the front panel, you'll see we've included what information is needed as the COM port and the axes names. If we open the sample Z stage front panel, we have the stage name and then the axis name. Let's try and take a step and make sure the stage is working as expected. Everything looks fine here, so we'll continue down the list and keep testing the devices. And now we get to the Hamamatsu Orca Flash. For some reason, when you initialize this camera in LabVIEW, the computer always hangs for a few seconds, so make sure you wait a bit before you start trying to click on things after starting this camera. Okay, now we've worked our way through all the devices and everything is working. To quit, we can click the Quit All Device Engine buttons, we can click the Quit Device Panel button, or we can stop the device engines individually and then quit. It doesn't really matter. So there are two common problems that might cause a device engine not to run when you're setting up. The first potential problem is if you forget to include the axis name or if you put in the wrong axis name. The second problem is if there's a mismatch between the baud rate hardwired on the device engine block diagram and the controller. For some of the PI controllers, you need to set physical dip switches so the baud rate of the controller matches the baud rate set in LabVIEW. Thanks for watching this video. This work has been entirely supported by the Wellcome Trust and carried out at the Gurdon Institute, which is part of the University of Cambridge, UK. Go ahead and click the link on screen now if you want to jump to the next video where we continue the setup process.